don't know why I did that. It's completely clear. So x squared minus 36. If we factor an x out of each of those terms in the denominator, you have x times x squared minus 2x minus 24. Okay. So we know our numerator is a difference of squares. So x squared minus 6 squared is x minus 6, x plus 6. Okay. And we know this here, this can be factored into x minus 6, x plus 4. Okay. So we actually have an x minus 6 that can cancel out. Okay. So we know our f of x can now be reduced to x plus 6 over x times x minus 6 times x plus 4. Oh, I'm sorry, I already canceled out the x minus 6. Bless you. X plus 4. Here we go. Okay. So now that you've simplified it, now you look for all the values that make the denominator 0. So after simplifying, find all values that makes the denominator equal 0. Okay. So we know for a fact that x times x plus 4 cannot equal 0. Okay, so that means that x can equal 0 and x plus 4 can equal 0. So that means that x can equal 0 and subtract 4 from both sides, x can equal negative 4. Okay, so those are your vertical asymptotes. All right. Any questions on that one? All right. I'll leave that up for a few more. Bless you. All right. Okay, so we review those. So we have our vertical asymptotes, our x-intercept, and our y-intercept. We did those because now we're going to go over our horizontal asymptotes. Okay, so let's say if we let f of x equal our general formula for polynomials. Say a(n minus 1, xn minus 1, plus all the way down to your x coefficient plus your constant coefficient all over. Let's say we'll call it a b all the way to your x coefficient and your last constant coefficient. Okay. So no matter what the polynomial is, if you're looking just for your horizontal asymptote, there are three things you want to look for, and they all just involve your lead coefficient. Okay. So you don't have to worry about anything else when looking for your horizontal asymptote. Those two are the only things you're worried about. Okay. So if your exponent, oh, sorry about that, that should be m. Let me straighten that out. M minus 1. Yeah, there we go. Okay. Now, if the coefficient of your numerator, not coefficient, exponent of your numerator is bigger than the exponent of your denominator, or smaller rather, the x-axis is your horizontal asymptote. Okay. So if you had something x squared over something x to the third, then that's when you know your x-axis would be your asymptote. Okay. So if you have, let's say, if they're both equal, say the exponent of your numerator is the same as the lead exponent in your denominator, then whatever those two coefficients are, that will be your horizontal asymptote. Okay. Now, if the exponent of your numerator is bigger than the exponent of your denominator, then there is no asymptote. Well, horizontal at least. Okay, so all three of those just compare the exponents for your numerator and denominator, at least your lead exponents. Just compare your lead coefficients. Lead exponents. All right, so let's get do I have enough room? I'll start another sheet. Okay. Oh, bring that up. All right. Okay, so let's say, for example, let's say find the horizontal asymptotes for, let's say for problem A, say f of x equals 2x over 3x squared plus 1. Say for problem B, say g of x is equal to 2x squared over 3x squared plus 1. Oops, straighten that 2 up a little bit. And let's say for problem C, let's say h of x is equal to 2x to the third over 3x squared plus 1. Okay, so the only difference between those three is the exponent of the numerator. Okay. So we see for the first one, so for f of x equals 2x, say to the first, over 3x squared plus 1. In this case, n is less than m. So the exponent in the numerator is less than the exponent in the denominator. Okay, so that means the x-axis is the horizontal asymptote. All right, so any questions on that one? All right, so as you can see, we didn't pay attention to anything else other than those two coefficients. Well, let me clear up that one a little bit. It's a little bit messy. There we go. Okay. Now for B, we do the same thing. All we're going to worry about are the lead coefficients. Okay, so for g of x equals 2x squared over 3x squared plus 1. Again, just like here, we just compared those two. Compare those two. But in this case, the two exponents are equal. N equals m. Okay, so when n is equal to m, okay, so the exponent in the numerator is equal to the denominator exponent. Okay, so that means those two lead coefficients is our horizontal asymptote. So if you had 5x squared over 7x squared, your horizontal asymptote would be 5 over 7. Any questions on that so far? Okay. All right, so for C, we know for h of x is equal to 2x to the third over 3x squared plus 1. Again, we're just going to compare those two. But in this case, n is bigger than m. Okay, so the exponent of the numerator is bigger than the exponent of the denominator. or greater than, bigger than the denominator. Okay, so when that's the case, there is, oh, sorry about that. If that's the case, then there is no horizontal asymptote. All right, so any questions on that one? Okay. So remember your horizontal asymptote, just a quick visual for it. Let's say if you have a graph and you have your x and your y. This is your horizontal asymptote. Then your graph will get close to that point and not cross it. Kind of like your vertical asymptote, where if you have x can't equal 3, it'll get close to 3 on either side, or it could get close to 3, but it'll never cross it. Let me horizontal. Why did I write vertical? I think just saying vertical made me think vertical. There we go. All right, so any questions on that one? Okay. Let's leave that up for a few seconds. All right. Okay, so now we're going to look at slant asymptote. Okay. So now to find a slant asymptote, you just use long division. And you kind of ignore the remainder. Okay, so use long division of polynomials. To find the slant asymptote. Now, if you can, you use the synthetic division. It's a little easier, but in a lot of cases, or in some cases, you won't be able to if there's a coefficient from the x. So we'll just say use long division as kind of a fail-safe. Okay, so ignore the remainder. All right, so for, let's say, f of x, equals x squared plus 2x plus 3 divided by x minus 1. Find the slant asymptote. Okay, so now we just divide it. Okay, so we divide our x squared plus 2x plus 3 divided by x minus 1. Okay. Now on this one you could have used synthetic division, but we'll get the extra practice with long division. Okay, so the first thing we want to do is get rid of that x squared. So x times x will give you x squared. So now you multiply. We have multiply, subtract, and then bring down. Okay, so x times x is x squared. X times -1 is negative x. So we multiply, now we subtract. Okay, so remember your negative x squared minus x will now give you negative x squared plus x. Okay, so x squared minus x squared is 0, so that disappeared just like we wanted. 2x, remember that's plus x now, is 3x. So we multiply, we subtract it, now we bring down. Okay, so now we want to get rid of the 3x, which means we have to multiply 3 by x to get that. Okay, so once again, we have to multiply, subtract. There's nothing else to bring down, so that would actually be the end of it. Okay, so 3 times x is 3x. 3 times -1 is -3. So we multiply it. Now we subtract. And remember, negative 3x minus 3, once you distribute that negative, becomes negative 3x plus 3. Okay, so 3x minus 3x is 0, so that disappeared just like we wanted. 3 plus 3 is 6. Okay, so we know that x squared plus 2x plus 3 divided by x minus 1 is equal to x plus 3 plus your remainder over your denominator, plus 6 out of x minus 1. Okay, so remember, you're kind of ignoring the remainder. You don't, you want to acknowledge it, but you don't really need it. So you just ignore the remainder. This is actually just all you want. So y equals x plus 3 is your slant asymptote. We'll bring that up some. Alright, and this is the actual graph for it. So neither one of those will cross that asymptote. Okay, so that's the equation for it. So once you graph your y equals x plus 3, you know no matter what values of x you plug in, they will not cross that asymptote. Hence the name of slant asymptote. Okay, so we can also see that 2 is bigger than 1, which is the same as n is greater than m. So since n is greater than m, there is no horizontal asymptote. Okay. The question didn't ask that. It was just one of those things that I figured I'd point out. All right. So any questions on that one? All right. So actually, if you see x equals 1, because 1 would make the denominator 0, if you notice, it also never crosses that 1. Well, I think 1 is probably about here. Okay. So you also have a vertical asymptote. Again, the question didn't ask for it. I just figured I'd point that out. All right. So any questions on this one? All right. So what we're going to do, these will also be sent with the notes. So what we're going to do is we're going to put all those together to identify graphs of rational equations. Well, that's going to shut off. Well, I'll write down the steps. Hopefully we'll beat the clock. If not, we'll restart it. Okay, so guidelines for graphing rational functions. So clean up that U a little bit. There we go. Okay, so let's see if we let f of x equals some p of x over q of x, where p of x and q of x are polynomials. Okay, so we don't know what type of polynomial, degree, or anything else. We just know that it's a polynomial on top of another polynomial. Okay, so the first thing you want to do is you want to factor and simplify, see if anything cancels out. So the first thing you want to do, factor and simplify if necessary. Kind of glance through the problems, most of them were already factored for you, but in case I missed one or two. Okay. If you have to factor it out, you want to cancel it to make sure. Okay. So the second step is to find your y-intercept. Which means you make your x equal 0. Or let's say your third step, find your x-intercept, which could be more than 1. So we'll put the s in parentheses as a just in case. Okay, so for your x-intercept, of course, make your y equals 0 or your f of x equals 0. Okay. So your fourth step, you want to find your vertical asymptotes. Okay. In other words, your denominator can equal 0. Okay. Now, for usually, because what they do is they give you kind of a list of graphs to choose from and say, okay, which one is the graph of this function? So now, normally, by the time you reach the third or fourth step, you pretty much eliminated the others. But just in case, we're going to add 2 more steps. Okay. So the fifth step is you want to find, if necessary, your horizontal asymptotes or your slant asymptotes. If necessary.